Our last example for the difference quotient is simplifying a difference quotient of a radical equation. So a very simple one, just the square root of x plus 5, but these can get a little bit tricky. If you have to do a problem like this, everybody should be able to do the first step, which is setting up the initial part of the difference quotient. Remember, we just take that x plus 5, we take out the x, and we put in x plus h, and this is f of x plus h. Take out the x, put in an x plus h. That's f of x plus h. Then we're going to subtract the original function, square root of x plus 5, the original f of x, and this whole thing is going to be over h. Now, this one is quite tricky, how to simplify it. So I'm going to recopy what we have here so that you can see how we're going to simplify this. And we're going to simplify it by doing something called multiply by the conjugate. Okay, what is the conjugate of a binomial? The conjugate of a binomial means take the thing that you have. In this case, we're going to take the x plus h plus 5 minus x plus 5. I forgot a plus sign here. So we're going to take the x plus h plus 5 minus x plus 5. That's our binomial. And what is the little sign here in the middle? It's a minus. The conjugate says do everything the same except you're going to change that sign in the middle from whatever it is to the other sign. So if it's a minus, make it a plus. If it's a plus, make it a minus. So we are going to multiply the numerator by the square root of x plus h plus 5 plus the square root of x plus 5. And that is the conjugate of that numerator. Now, you guys know how fractions work. If you multiply the top of a fraction by something, you have to multiply the bottom by exactly the same thing. And remember what we said about denominators in these problems? Once you write them, you're not going to mess with them ever again. So we're just going to make sure that we copy this same thing up here that we put in. You've got to do exactly the same thing on the bottom. So we have the same thing that we multiplied by on the top and the bottom because that's how we work with fractions. Now, the tricky part here is we have to multiply these two together. So what we're going to do is we're going to multiply x plus h plus 5 under a square root times the square root of x plus h plus 5. Notice that those are the same. Well, if we multiply the same thing by itself, isn't that just the same as squared, right? Now, the insides are where this is going to get a little tricky because we need to now multiply the insides and the outsides, these two together. And notice they're not the same. So if they're not the same, we're just going to write them exactly next to one another. So x plus h plus 5, that square root times the square root of x plus 5. So notice we just multiplied them by writing them next to each other. That means multiply. Now we're going to take the negative x plus 5 times that positive x plus h plus 5. And again, we're going to write them next to each other. And since it's a minus here, we get a negative times a positive. This will be a negative times that square root of x plus 5. And then our last thing that we're going to multiply is the square root of x plus 5 times the square root of x plus 5. We'll distribute it there. Well, what does it mean to have a square root times a square root? That's squared. And remember, one is negative and one is positive. So we're going to have a minus square root of x plus 5 squared. Now, this whole thing is over. The whole thing is still over h times that gross square root thing. So this looks really gross. It looks really gross, but actually it's going to simplify pretty nicely. So we're going to start by focusing our eyes right here on these two things. And what do you notice about those two things? Are they exactly the same, but one is positive and one is negative? Yeah. So what happens when you take something and you subtract the same thing? What's 7 minus 7 or 30 minus 30? It's 0. So these two things add to 0. They cancel each other out. So that whole center grossness is just gone. So all we're left with now is, what does a square root and a square do? Well, they are designed to be opposites. They cancel. So we have x plus h plus 5 left here. And then if we look over at this green bit, we have a minus and a square root squared. So minus that x plus 5. And be careful, we need to minus the whole thing, so we're going to put it in parentheses. And then we're over this big ugly mess, which isn't going to go away. It's just going to kind of stay a big ugly mess. X plus h plus 5 plus the square root of x plus 5. All right, now if we distribute that green bit on the top and then recopy everything, what have we got? We have x plus h plus 5 minus x minus 5 all over big gross denominator. And again, if it doesn't have an h, it should have an opposite to cancel. So x minus x, 5 minus 5. The only thing I've got left in this numerator is an h. So we're going to come up here. This is a messy problem. So we have h over h and ugly square roots. And now, see how this h is by itself, and we have an h down here. What's h divided by h? Well, what is 7 divided by 7 or 30 divided by 30? That is 1. You can't leave this numerator blank. It doesn't disappear. And this is in the denominator. It doesn't magically end up in the numerator. But you need something on the top. And think, what is h divided by h? That is 1. So our final simplified version of the difference quotient with square roots is x plus h plus 5 times the square root of x plus 5 in the denominator with a 1 in the numerator.